Emily will present the flashcard on coordination compounds in chemistry class 12.
So first comes the topic 3, Werner's theory of coordination compounds, definition of some important terms pertaining to coordination compounds, nomenclature of the coordination compounds, isomerism in coordination compounds, bonding in coordination compounds, and bonding in metal carbonyls, important and applications of coordination compounds. So first, that is a mnemonic for the topic 3.
What is this W?
It's Werner's theories. It is the definitions of the coordination compounds, nomenclature, isomerism, bonding of coordination compound and bonding of metal carbonyls and important applications. First, the coordination entity constitute a central metal atom or ion bounded to the fixed number of ions or molecules. It has three types: neutral complex, cationic complex, and anionic complex. As you can see, the first one is cobalt chloride 3, NH3 3 times, and nickel carbonyl group 4 times, and platinum uh, palladium chloride 2 times, platinum
Fluorine,
chloride, uh,
NH3.
NH3 twice.
Can you name this compound?
It is amine, sir.
What is that nomenclature?
It is tris.
Why tris?
So that is three
Ammonia means amine. So triamine.
triamine,
Mhm.
triamine,
Trichloro,
triamine, chloro,
trichloro,
trichloro,
cobalt.
cobalt.
This one.
And cationic complex, as you can see, it has the ionic nature 3 plus, and anionic complex has the ionic nature 4 minus.
But what about this? You are not mentioned.
So,
Cn2, this is plus means minus.
and it is a representation of a coordination compound. The first one represents it is central metal atom. It is also called as CMA and CMI. And the next one are the ligands, that is chloride and amine. And the 2 and 4 represents the coordination numbers of the complex. And the chlorine outside the coordination sphere is ionizable anion and the charge on the complex. It is a coordination
Sphere.
sphere.
Square bracket represents coordination sphere.
Ligands. Ions or molecule bound to central atom. Donate electron pair to the metal ions, also known as Lewis bases. Example, chlorine, hydroxyl, chloride, hydroxyl group, and
Ethylene,
diamine, and
oxalate.
oxalate. Types of
How do you call this chloride ligand in IUPAC?
chlorido or
This one?
hydrido,
Hydroxo.
hydroxo, and en.
Diethylene, ethylene diamine.
Oxalate,
Oxalato.
oxalato. And types of ligand are mono or unidentate, ambidentate, bidentate, chelate, polydentate.
What is chelating?
Sorry.
Ligand. It forms a ring structure.
It can.
Hmm.
Mono or unidentate contains only one donor atom and donates one pair of electron to the metal ion. Examples are amine, water,
It is not amine, ammonia.
ammonium, H2O.
Ammonium, no ammonium. Ammonium means NH4 plus. Ammonia is a neutral molecule. What is this? Water. That is also neutral molecule.
And all the halogens.
Halides. Chloride, bromide, fluoride, iodide, cyanide, hydroxyl.
And next is bidentate that contains two donor atoms through which it binds the metal ion. Example are ethylene diamine, that is also represented at En, oxalate ion, that is OH. Polydentate contains more than two donor atoms. Example, ethylene diamine tetraacetate ion, EDTA.
So what is the, at how many places it can have the point of attachment with the central metal atom? Excellent.
Ambidentate contains two donor atom and can bind to the metal ion through either of the atom. This shows a difference between the bidentate and ambidentate. While seeing the bidentate, we can see that it cannot bind to the metal ion through either side of the atom. But ambidentate can bind the metal ion through either side of the atom. That is nitro N if the representation is NO2. Nitrito O if O comes in front, that is ONO.
So it is connected through O with the central metal.
Yes, sir.
Similarly,
Similarly with thiocyanide, when it is
what do you mean by
connected
thio? Sulfur.
sulfur.
So it is connected through sulfur, thiocyanate. Oh, yes. Thiocyanate to N means
It
it's
is
connected to N, nitrogen.
Chelating, di or polydentate ligand which forms a ring when it binds to the metal ion through two or more donor atoms simultaneously. Forms 5 or 6 membered rings tend to make more stable complexes. Stability of the complex is proportional to number of chelating ligands.
So with the increase of number of chelating ligands, the stability will also increase.
Nomenclature. The formula for nomenclature is number of ligands plus name of the ligands plus name of the central metal atom plus oxidation state of the central metal atom. That should be represented in Roman letters. Anionic ligands. These are some examples. F minus is fluoxide. Cl minus is chlorido. Br minus is bromido. N3 minus is acido. N to the power 3 minus.
Anionic answer, F minus means fluorido. Why fluoxide? Fluorido. Fluorido, chlorido, bromido, right?
Acido, nitro, and amido.
Nitrido.
Nitrido and amido. Acetato, sulfato, and oxalato.
If it is SO3 2 minus
Sulfite.
sulfito.
Here are some example of neutral ligands, that is amine, aqua.
You have to be very careful.
If
That should be
NH2
two
comes,
double F.
double. Aqua and nitrosyl, carbonyl, thiocarbonyl, dinitro, dinitrogen. En represents ethylene diamide. And positive ligands are nitrosonium, nitronium, oxygenisium, and
Oxygenium.
oxygenium and anilinium.
Anilinium.
Anilinium. Now, next aspect of the topic tree is isomerism. There are two types, structural isomerism and stereoisomerism. Structural isomerism consists of ionization isomerism, linkage isomerism, coordination isomerism, and hydrate isomerism. Let me explain in one word.
So you can develop there is a mnemonic for that.
Yes.
You can put it chill. Right?
Yes.
And what about this? Go. What about this? Ice. So ice, chill, go. Geometrical isomerism, optical isomerism.
Werner's theory. Each metal ion shows two types of valencies. Primary valency, ionizable and corresponds to the oxidation number of central metal atom. Satisfied by anions, non-directional in nature. Secondary valency, non-ionizable and corresponds to the coordination number. Does not satisfy by anions and directional in nature. Metal ion should satisfy both types of valencies. Ions or groups bounded to secondary valency have characteristic spatial arrangements. These are the postulates of Werner's theory. And the experiment follows as COCl3 plus NH3 gives different complex in AgNO3 and AgCl. That N depends on the number of primary valencies. Metal carbonyls. Homoleptic carbonyls shows show metal carbon bond which possess both sigma bond and pi bond character. Sigma bond ligand to metal. First, in vacant pair, it connects with containing lone pair with triple bond in carbon and oxygen bond that gives metal combines with the vacant and containing lone pair bond. This is pi bond, back bonding metal and carbon. Filled orbitals plus that gives
Orbitals of the metal complex.
Plus carbon and oxygen triple bond that gives a vacant anti-bonding bond that also can be represented as the synergic bonding strengthens the bond. Pi bond overlap is perpendicular to the plane of sigma bond. Crystal field theory. Assumptions. Ligands are considered as point charges. Anionic ligand gives negative point charges. Neutral ligands dissipates. Crystal field splitting. Repulsion between uh, repulsion of ligands and d orbital electron of the metal takes place. D orbital split into T2G and EG orbitals. T2G generates triple E, DXY. Degenerates triple E.
Degenerate triple E.
DXY, DYZ, and DX.
So it's a triplet. This is called triplet and this is doublet.
EG
so
is
triplet and doublet means so that is you got the d orbital. You got 1, 2, 3, 4, 5. So this one is dxy, dyz, dxz, and this is dx squared minus y squared and d is z squared. So when it splits, when the when the d orbital splits, these are called triplets, T2G, and this is W, EG. Okay.
Extent of splitting is proportional to number of ligands and their position around the metal. These are the EG, that is
splitting.
These are the EG, the doublets. They will be along the axis. These are the triplet T2G. They will be between the axis. As you can see, the Y, Z, and X are intersecting each other.
And these are
doublets.
Means they are
passing on.
Oriented towards oriented along the axis. X and. Okay, very good.